Welcome to Night Echoes. Tonight we're venturing into one of society's most critical yet dangerous workplaces, the power plant. These massive industrial facilities generate the electricity that powers our cities. But behind their imposing walls and razor wire fences, security guards work alone through the night, monitoring equipment that could kill with a single misstep. Let's begin. My name is Marcus Chun, and I spent 3 years as a security guard at the Riverside Power Generation Plant in Southern California. What I'm about to tell you happened during my final month there. And it's the reason I left that job and never looked back. The Riverside plant is one of those older facilities built in the 1960s that still runs on massive diesel generators for backup power. During peak demand or emergency situations, these generators kick in to supplement the main grid. The generator room houses 8 industrial diesel engines, each the size of a small building, capable of producing enough electricity to power a small city dot as night security. My job was to patrol the facility every 2 hours, checking sensors, reading meters, and ensuring no unauthorized personnel were on site. The generator room was always my least favorite stop. Even when the generators weren't running, the room felt oppressive. The air was thick with the smell of diesel fuel and electrical ozone, and the concrete walls seemed to absorb sound in a way that made your footsteps echo strangely. The generators themselves were intimidating pieces of machinery. Each one stood 12 feet tall and 30 feet long, painted industrial yellow with warning labels in 3 languages. When they were running, the noise was deafening. But when they were silent, they somehow felt even more ominous. Like sleeping giants that might wake at any moment. It was during my shift on November 15th that I first encountered him. I just finished my 2 a.m. patrol and was making my way through the generator room when I heard something that made me stop cold. Over the constant background hum of the facility, I could hear someone working on one of the generators. The sound was unmistakable, the metallic clanking of tools against machinery, the soft scraping of components being adjusted. I called out, "Hello? Who's there? You're not supposed to be in here without authorization." There was no response, but the sounds continued. I followed them to generator number 5, one of the older units scheduled for maintenance the following week. The sounds were definitely coming from inside the engine compartment, but when I circled around to investigate, I found nothing. No tools, no maintenance personnel, no sign that anyone had been there at all. I checked the access logs for the generator room. According to the digital records, no one had entered or exited the facility since my shift began at 10 p.m. The security camera showed only me walking through the room. Yet I had clearly heard someone working on that generator. I reported the incident to my supervisor, Tom Bradley, when he arrived for the morning shift. Tom had worked at Riverside for over 15 years and had seen just about everything. He listened to my account with the patient expression of someone who'd heard similar stories before. "Generator 5, Tom said thoughtfully. "That's interesting. You know, we lost a maintenance worker in that room about 8 years ago. Frank Kowalski. Been with the company for 23 years, knew those generators better than anyone." Tom explained that Frank had suffered a massive heart attack while performing routine maintenance on Generator 5. He'd been working alone during a night shift, just like the maintenance schedule required for that particular type of service. Frank was found the next morning, still wearing his safety harness, tools laid out around him as if he'd simply paused in the middle of his work. Frank was one of those guys who lived for his job, Tom continued. Never missed a day, never complained about working nights or weekends. The generators were like his children. He'd been maintaining those particular engines since they were installed in the early 1980s. I thought about what Tom had told me for the rest of that day, but I tried to convince myself it was just a coincidence. Old buildings make strange sounds, and it's easy for an isolated mind to interpret mechanical noises as something more sinister than they actually are. But 3 nights later, It happened again. This time I was prepared. I had my flashlight ready and my phone set to record audio as I approached the generator room. The sounds were more distinct this time. I could hear the specific rhythm of someone checking belt tension, the careful tapping of a wrench against metal components, even what sounded like a person humming quietly while they worked. I moved slowly toward generator 5, trying to be as quiet as possible. The sounds continued, unhurried and methodical, as if whoever was working had all the time in the world to complete their task. I could see the generator clearly in my flashlight beam, but there was no one there. Yet the sounds of maintenance work continued, coming from the exact location where I was pointing my light. I started recording audio and called out again. "Frank, is that you, Frank Kowalski?" The sounds stopped immediately. The silence that followed was absolute, more complete than the usual quiet of the generator room. Even the background electrical hum seemed muted. I waited for several minutes, but the sounds didn't resume. When I reviewed the audio recording later, it captured everything I'd heard: the tools, the humming, even my voice calling Frank's name. But there was something else on the recording that I hadn't noticed in person. In the background, barely audible, was the sound of someone breathing heavily, as if they were exerting themselves with physical labor. Over the next few months, I continued to witness Frank's nocturnal activities, but they evolved beyond simple maintenance work. Frank began conducting what appeared to be comprehensive system audits, methodically testing every aspect of the generator room's operation with the thoroughness of someone preparing for a major inspection. I would hear him working through complex diagnostic procedures, testing backup systems that were rarely used, and performing preventive maintenance on equipment that wouldn't normally be serviced for months. His phantom work schedule became so predictable that I could anticipate which generators he would focus on during any given night based on their operational history and maintenance records. Most remarkable aspect of Frank's continued presence was his adaptation to technological changes that had occurred since his death. The generator room had been upgraded with digital monitoring systems, computerized control interfaces, and new safety equipment that hadn't existed during Frank's lifetime. Yet somehow, he had learned to work with these modern systems as effectively as the original mechanical equipment he'd known. I observed Frank interacting with digital displays, adjusting computer-controlled parameters, and responding to automated alarms with the same expertise he'd shown with traditional mechanical systems. His knowledge had somehow expanded beyond what he'd possessed in life, growing to encompass the technological evolution that had occurred in his absence. During particularly complex maintenance sessions, I could hear Frank working with what seemed to be a full team of assistants. The sounds of multiple people coordinating their activities, sharing tools, and discussing technical procedures suggested that Frank wasn't working alone in his phantom state. He appeared to be leading a team of deceased maintenance workers who were continuing their professional responsibilities. Together, the collaborative nature of the phantom maintenance work became more apparent during major system tests that required coordination between multiple generators. I would hear the sounds of several teams working simultaneously on different equipment, communicating with each other through hand signals and technical jargon, implementing complex procedures that required precise timing and coordination. These phantom maintenance teams seemed to include workers from different eras of the plant's operation, bringing together decades of accumulated expertise and experience. Frank was serving as the coordinator for a group that represented the entire institutional memory of generator room operations, accessing knowledge and techniques that spanned multiple generations of maintenance practices. The medical examiner's report on Frank's death indicated that he'd suffered a massive cardiac event, but it had taken several hours for his body to be discovered. The maintenance he'd been performing on Generator 5 was described as routine preventive service, checking fluid levels, testing electrical connections, and replacing worn components. What struck me most was the detail that Frank had been found with his work partially completed. His tools were organized exactly as he'd left them, suggesting he'd been in the middle of a specific procedure when the heart attack occurred. The subsequent maintenance team had to finish Frank's work before the generator could be returned to service. Over the following weeks, my encounters with Frank became more frequent and more detailed. I would hear him working at various points throughout the generator room, always focused on preventive maintenance tasks. Sometimes I could hear him moving between generators, his footsteps echoing in the cavernous space. Though I never saw any visual evidence of his presence, the sounds were always consistent with legitimate maintenance work. I learned to recognize the specific noises associated with different procedures, the careful tapping that indicated belt adjustment, the rhythmic scraping that meant he was cleaning electrical contacts, the soft mechanical clicking that accompanied gauge readings. I began timing these sessions and discovered they followed a pattern. Frank's phantom maintenance work always occurred during the same hours when he would have performed his actual job. He worked methodically, never rushing, taking the time to do each procedure properly. It was exactly what you'd expect from a dedicated maintenance professional. I also noticed that the generators Frank worked on consistently performed better than the others. Their efficiency ratings improved, they required fewer emergency repairs, and they started more reliably during peak demand periods. It was as if Frank's posthumous attention was actually benefiting the equipment. The other security guards began to report similar experiences. Jake Morrison, who worked the weekend night shift, told me he'd heard Frank working on Generator 3 during a particularly busy period when the plant was running at maximum capacity. Sarah Walsh, one of the few female guards, said she'd heard Frank humming the same song every night, a tune she later identified as Working Man by Rush, which Frank's former co-workers confirmed had been his favorite song. But my most significant encounter with Frank occurred during an actual emergency. On December 8th, a winter storm knocked out power to a significant portion of the county, and Riverside was called upon to provide backup generation. All 8 diesel generators needed to be brought online simultaneously, something that hadn't happened in over 2 years. I was in the control room, monitoring the startup sequence when Generator 5 failed to start. According to the computer diagnostics, there was an electrical fault in the ignition system, but the maintenance team wouldn't arrive until morning. The plant supervisor was considering taking Generator 5 offline completely, which would significantly reduce our capacity during a critical period. I decided to go down to the generator room to see if I could identify the problem visually. As I approached Generator 5, I could hear Frank working on it. The sounds were more urgent than usual, focused and determined. I could hear him troubleshooting the electrical connections, testing circuits, and making adjustments. I stood there for nearly an hour, listening to Frank work on the problem. The sounds were detailed and specific. I could hear him removing access panels, testing connections with what sounded like a multimeter, and making careful adjustments to components. It was like listening to a master craftsman solve a complex puzzle. Finally, the sound stopped. I waited for a few more minutes, then called the control room and suggested they try starting Generator 5 again. To everyone's surprise, it started immediately and ran perfectly for the rest of the emergency period. The maintenance team that examined Generator 5 the next day found that several electrical connections had been cleaned and tightened. The ignition timing had been adjusted to optimal specifications, and a faulty relay had been replaced with a spare from the parts inventory. All of the work was performed to company standards using the proper tools and procedures that the maintenance supervisor couldn't explain how the repairs had been completed. The parts inventory showed that the replacement relay had been taken from storage, but there was no record of anyone accessing the parts room. The tools that would have been needed for the job were all accounted for in their proper locations. According to every official record, No one had worked on Generator 5 between the time it failed and the time it was successfully restarted, but I knew who had fixed it. Frank Kowalski had completed his final maintenance task. After that night, I never heard Frank working in the generator room again. The phantom sounds of tools and maintenance work stopped completely. It was as if Frank had finished something important and was finally able to rest. Left Riverside Power Plant 3 weeks later. The official reason was a better job offer, but the truth was that I'd witnessed something that challenged my understanding of life and death. Frank Kowalski had loved his job so much that death hadn't been able to stop him from completing his responsibilities. He'd continued working for 8 years, maintaining the generators with the same dedication he'd shown in life, until one final emergency allowed him to prove that some commitments transcend mortality. The generator room still operates perfectly today. Generator 5, the unit Frank spent so much time maintaining in both life and death, has one of the best reliability records in the plant's history. The maintenance staff sometimes joke that Frank left it in such perfect condition that it practically runs itself, but I know the truth. Frank Kowalski finished his shift. I'm David Petrov, and I worked as a security supervisor at the North Point Nuclear Facility in Oregon for 7 years. What I'm going to tell you about happened during the winter of my 5th year there. And it's something that still keeps me awake at night. North Point is one of the largest nuclear power plants on the West Coast, employing over 800 people during day shifts. But at night, the facility becomes a very different place. During overnight hours, the skeleton crew consists of just 12 people: essential operators, maintenance staff, and security personnel. The plant runs itself through automated systems, with human oversight limited to critical monitoring and emergency response. As security supervisor for the night shift, I was responsible for coordinating patrols throughout the massive facility. North Point covers over 400 acres and includes the main reactor building, the Turbine Hall, administrative offices, and dozens of auxiliary structures. My command post was located in the primary control room, where I had access to security monitors, communication systems, and the facility's computerized access logs. The control room itself is an impressive space, a semicircular chamber filled with monitoring equipment, computer terminals, and communication systems. Banks of screens display everything from reactor core temperature to electrical grid status in real time. During normal operations, the room buzzes with activity. But during night shifts, it becomes eerily quiet, with only the soft humming of electronics and the occasional alert tone. One of my primary responsibilities was maintaining the security log, a detailed record of all personnel movements, system alerts, and patrol reports throughout the night. This log was kept both in digital format and as a physical backup in a bound logbook that had been used for decades. The practice of maintaining handwritten logs was a holdover from the plant's early days, but regulations required us to continue the tradition as a redundancy measure. It was during my routine review of the night logs that I first noticed something unusual. While going through the previous week's entries, I found handwritten log entries that I didn't remember making. The handwriting looked similar to mine, but the details were wrong. The entries described patrols to areas of the plant that weren't part of our standard security rounds, and they referenced personnel who weren't scheduled to be on duty. For example, one entry from the previous Tuesday read, 0230 hours, completed patrol of reactor, building level B3, observed maintenance team replacing primary coolant pump seals. Team leader Johnson reports work proceeding on schedule. No security concerns noted. The problem was that level B3 of the reactor building had been sealed off since 1987, following a containment breach during a maintenance accident. No maintenance work was authorized for that area, and there was no employee named Johnson on the night maintenance roster. I initially assumed I'd made an error while tired and somehow confused the details. Night shift work can be mentally demanding, and it's easy to make mistakes when you're working alone for 12 hours. But as I continued reviewing the logs, I found more entries that didn't match my memory or the official duty rosters. These mysterious entries always described routine maintenance work being performed by teams of workers I'd never encountered. The handwriting was consistent, and the entries followed proper log format, but they documented activities that couldn't have actually occurred. I decided to review several months' worth of security logs to see if this was an ongoing issue. What I discovered was disturbing. The mysterious entries appeared regularly, dating back several years, but they weren't consistent with any single person's handwriting. It was as if multiple security supervisors had been documenting the same phantom maintenance work over an extended period. I brought the issue to my day shift counterpart, Monica Rodriguez, who had been working at North Point for over 12 years. Monica examined the logs with growing concern as I showed her the entries that didn't match reality. "David," Monica said carefully, "I think you need to see something." Monica led me to a filing cabinet in the administrative office that contained archived security logs dating back to the plant's opening in 1978. She pulled out several volumes from the early years and showed me entries that were remarkably similar to the ones I'd been finding in current logs. The archived entries described the same type of phantom maintenance work performed by teams of workers in areas that had been restricted or sealed off for decades. The maintenance activities were always routine, replacing components, checking systems, performing preventive care, but they were taking place in parts of the plant where no human was authorized to enter. "We've all seen these entries," Monica explained. "Every security supervisor who's worked nights at North Point has found them in the logs. Management knows about it, but they've never been able to explain it. The official policy is to ignore them and focus on actual security concerns." Monica showed me personnel records from North Point's early years, during the initial construction and commissioning phases. Between 1978 and 1983, the plant had employed nearly 3,000 construction workers, maintenance technicians, and engineers. Many of these workers had spent years at North Point, learning the facility's systems and developing expertise in its unique operational requirements. "The thing is," Monica continued, "a lot of those early workers died young. Construction accidents, industrial exposure, workplace incidents. The safety standards weren't what they are now. Some estimates say we lost over 200 workers during the first 5 years of operation." Monica explained that the phantom log entries always described maintenance work being performed by teams using the names and job titles of workers who had died during North Point's early years. The maintenance activities they describe were always legitimate procedures, performed in areas where those workers would have actually spent their time during the plant's construction and initial operation. I decided to conduct my own investigation. During my next night shift, I positioned myself in the control room with a clear view of the security logbook and waited to see if I could observe myself making any entries. I didn't remember. I also set up a video camera to record the logbook area throughout the night, around 3:15 a.m. While I was monitoring the security cameras from other areas of the plant, I noticed that someone had added a new entry to the logbook. When I examined it, the entry read, 0315 hours maintenance team in Turbine Hall East reports successful replacement of bearing assembly on generator 2. Team leader Williams confirms all safety protocols observed. Work completed without incident. The problem was that generator 2 had been offline for 6 months due to a planned overhaul, and there was no one named Williams on any current maintenance roster. More concerning was that I had no memory of writing the entry. Despite being alone in the control room for the entire night, when I reviewed the video footage, it showed me clearly writing the entry with my own hand. But watching the video felt like observing someone else's actions. The person on screen moved with deliberate purpose, writing detailed technical information that I didn't consciously know. It was my body performing actions that my mind hadn't initiated. Over the following weeks, I became obsessed with understanding what was happening to me. I researched the history of every worker mentioned in the Phantom log entries, cross-referencing their names with personnel records and accident reports from Northpoint's early years. What I discovered was that the Phantom entries were written by workers who had died while performing the exact types of maintenance they described in the logs. Williams, for example, had been the lead turbine technician from 1979 to 1982, when he was killed in an industrial accident involving Generator 2. Johnson had been responsible for reactor coolant system maintenance until he died of radiation exposure in 1983. The Phantom workers weren't just documenting random maintenance activities, they were continuing to perform their specific job responsibilities, the same work they'd been doing when they died. Each entry described procedures that were within their areas of expertise, using the technical language and safety protocols they would have known in life. I began timing these episodes and discovered they occurred during the same hours when the original workers would have performed their actual job duties. Williams always wrote entries between 3 a.m. and 4 a.m., which had been his regular shift time. Johnson's entries appeared around midnight, matching his old work schedule. The most disturbing aspect was that I could feel their presence while the entries were being written. During these episodes, I retained awareness of what was happening, but I wasn't in control of my actions. It was like being a passenger in my own body, observing as someone else used my hand to document their work. I could sense their dedication to their jobs, their concern for the plant's operational safety, and their frustration at being unable to continue their work in the normal way. These weren't malevolent spirits trying to cause harm. They were dedicated workers who had loved their jobs, so much that death hadn't been able to stop them from fulfilling their responsibilities. The Phantom workers seemed to understand that they needed a living person to physically write their log entries. I became their means of maintaining the documentation they'd always considered essential to proper plant operations. Through my hand, they could continue to report that their maintenance work was being completed properly and safely. I also discovered that the maintenance work described in the Phantom entries was actually being performed. During routine inspections of areas mentioned in the logs, maintenance supervisors would find that components had been serviced, systems had been adjusted, and preventive care had been completed, all to the exact specifications described in the Phantom entries. Equipment in areas where Phantom maintenance was reported consistently showed improved performance and fewer failures than similar systems elsewhere in the plant. It was as if the Phantom workers were actually maintaining their equipment with the same skill and dedication they'd shown in life. My most profound encounter with the Phantom workers occurred during a serious emergency. In February, a severe ice storm knocked out external power to the plant, forcing us to rely entirely on backup systems. This type of situation requires intensive coordination between all operational teams, and every system needs to be monitored carefully. During the emergency, I found myself writing log entries almost continuously, documenting maintenance activities throughout the plant, but I wasn't consciously controlling what I wrote. The Phantom workers were using my hand to coordinate their emergency response, communicating with each other through my logbook entries as they worked to keep critical systems operational. Through my hand, Williams reported on generator status, Johnson provided updates on reactor coolant systems, and dozens of other Phantom workers documented their efforts to maintain plant safety during the crisis. I became a communication hub for a maintenance team that existed only as consciousness and memory. The emergency lasted 18 hours, and throughout that time, North Point's systems performed flawlessly. Every piece of critical equipment functioned exactly as needed, despite the plant being pushed to its operational limits. According to the day shift engineers, some systems actually performed better during the emergency than they did under normal conditions. When the crisis ended, the phantom log entries stopped as abruptly as they'd begun. I was left exhausted, not from physical exertion, but from serving as a conduit for the intense focus and dedication of workers who had refused to let death interrupt their service to the plant. I continued working at North Point for 2 more years after that, and the phantom log entries continued as well. I learned to accept that I was part of something larger than myself, a continuous chain of dedicated workers who had committed their lives to keeping the plant operational and safe. When I finally left North Point to take a position at another facility, I made sure to brief my replacement about the phantom logs. I explained that he would sometimes find himself writing entries he didn't remember making, documenting maintenance work performed by people who existed only as memory and dedication. My replacement initially thought I was joking, but within a month, he called to tell me he'd found his first phantom entry. He'd written a detailed report about bearing maintenance in the Turbine Hall, using technical terminology he didn't understand, documenting work performed by a team leader whose name he'd never heard. The phantom workers at North Point continue their duties today, maintaining the plant through the hands of living security supervisors who serve as their connection to the physical world. They represent the ultimate commitment to job responsibility, a dedication so strong that death cannot break it. The North Point nuclear facility has one of the best safety records in the industry, with equipment reliability that exceeds industry standards. The plant's success isn't just due to modern technology and current staff expertise. It's also maintained by phantom workers who refuse to let their deaths interrupt their service to a facility they helped build and commission over 4 decades ago. Their commitment reminds us that some responsibilities transcend mortality, and that dedication to important work can create bonds stronger than death itself. Massive electrical substation at night, towering transmission towers and transformers crackling with electricity. Security guard trapped between dimensions visible as translucent figure. High voltage warning signs, electrical arcing creating supernatural lighting effects, industrial maze of power equipment. My name is Elena Vasquez, and I worked as a security coordinator at the Metropolitan Power Grid's Central Distribution Station in Nevada for 4 years. What happened to me and my partner during the spring of 2019 changed my understanding of electricity, consciousness, and the space between life and death. The Central Distribution Station is one of the largest electrical substations in the Southwest, covering nearly 200 acres and handling power distribution for over 800,000 customers. The facility consists of massive transformers, switching equipment, and transmission lines carrying electricity at voltages up to 500,000 volts. Enough power to instantly kill anyone who comes too close to the wrong equipment. As security coordinators, my partner Jake Morrison and I were responsible for monitoring the entire substation during night shifts. The facility is largely automated, but human oversight is required for safety monitoring, emergency response, and protection against sabotage or theft. Our primary concern was ensuring that no unauthorized personnel entered areas where the electrical hazards could be fatal. The substation operates at voltages so high that the electricity creates its own sound, a constant crackling, buzzing, and humming that fills the air with electrical energy. During certain weather conditions, you can actually see the power arcing between transmission lines, creating an almost supernatural light show in the darkness. Working in that environment requires constant awareness that you're surrounded by forces that could kill you instantly if you make a mistake. Jake and I had been working together for 2 years when we encountered Thomas Brennan. According to the personnel records we later accessed, Thomas had been an electrical contractor who worked on the original construction of the Central Distribution Station in the 1980s. He'd spent nearly 3 years installing and testing the high-voltage equipment that formed the foundation of the facility's electrical grid. Thomas died in 1987 during the final commissioning phases of the substation. He'd been performing voltage tests on a newly installed 345,000-volt transformer when something went catastrophically wrong. The official investigation concluded that Thomas had somehow been exposed to electrical energy far beyond what the human body can survive. His death was instantaneous, but the circumstances were never fully explained. My first encounter with Thomas occurred during a routine patrol on April 18, 2019. Jake and I were walking through the transformer yard, checking the safety barriers around the high-voltage equipment, when I noticed someone working near Transformer Bank 7. This was concerning because no maintenance was scheduled for that area, and unauthorized access to the transformer yard was extremely dangerous. I called out to the figure, warning them about the electrical hazards, but they didn't respond. As Jake and I approached closer, I could see that the person was wearing the type of safety equipment used by electrical contractors: a hard hat, safety vest, and specialized insulated gloves designed for high-voltage work. They appeared to be testing connections on the transformer using some kind of electrical measuring device. "Hey," Jake shouted. "You need to get out of there immediately. That equipment is energized." The figure looked up at us, and I got my first clear look at Thomas Brennan, though I didn't know his name at the time. He appeared to be a man in his 40s, with graying hair and the weathered face of someone who'd spent years working outdoors with dangerous equipment. His expression was focused and professional, like someone who understood exactly what they were doing and was confident in their abilities. What struck me most was that Thomas seemed completely unaware of any danger. He was working with casual familiarity around equipment that could kill him instantly, handling electrical connections with the relaxed confidence of an expert. But something about his appearance was wrong. His edges seemed blurred, as if he were slightly out of focus, and his safety equipment looked outdated, like gear from decades earlier. Thomas acknowledged us with a professional nod, then returned to his work. Jake and I were frozen in uncertainty. We needed to get this person away from the dangerous equipment immediately, but approaching him would put us in the same life-threatening situation. I called the control center to report an unauthorized person in the transformer yard and request immediate assistance. While I was on the radio, Thomas finished whatever he'd been doing and began walking toward another transformer bank. As he moved, I noticed that his footsteps made no sound on the gravel surface of the yard. Jake and I followed at a safe distance, staying outside the marked danger zones while keeping Thomas in sight. He moved through the substation with obvious familiarity, navigating between transformer banks and switching equipment with the confidence of someone who knew exactly where everything was located. His route took him to areas that required specialized knowledge to access safely. Thomas spent the next 20 minutes performing what appeared to be routine electrical testing on various pieces of equipment. He moved systematically from transformer to transformer, spending several minutes at each location taking measurements and making notations on a clipboard that he carried. His work appeared professional and methodical, like someone following a specific testing protocol. The facility maintenance supervisor arrived about 30 minutes after my initial call, along with 2 electrical engineers and additional security personnel. When I pointed out Thomas's location near Transformer Bank 12, they looked confused. "I don't see anyone," the maintenance supervisor said. "Are you sure there's someone there?" Jake and I could both see Thomas clearly, but the other personnel couldn't see him at all. Thomas was directly in front of us, less than 50 feet away, working on electrical connections with obvious expertise, but he was completely invisible to everyone else. the maintenance supervisor used binoculars to examine the area where we'd indicated Thomas was working. "I don't see any signs of unauthorized access," he reported. "No footprints, no disturbed equipment, no evidence that anyone has been in that area." But Jake and I continued to observe Thomas as he completed his testing routine. We could see him, making final notations on his clipboard, organizing his tools, and preparing to leave the area. His actions were deliberate and professional, like someone finishing a scheduled work assignment. As Thomas began walking toward the exit, one of the electrical engineers decided to investigate the equipment where we'd seen him working. Using specialized high-voltage testing equipment, the engineer discovered that several critical electrical connections had recently been adjusted and optimized. The voltage readings were now precisely calibrated to specifications that exceeded the original installation standards. "This is interesting," the engineer reported. "Someone has definitely been working on this equipment recently. These connections have been improved beyond their original configuration. Whoever did this work knew exactly what they were doing." The engineer's measurements showed that the electrical systems Thomas had worked on were now operating at peak efficiency. Power flow had been optimized, voltage regulation had been improved, and potential failure points had been eliminated. The work represented the skill level of a master electrician with decades of experience in high-voltage systems, but according to the facility's access logs, no maintenance personnel had been authorized to work in the transformer yard for over 2 weeks. The specialized tools required for the type of work that had been performed were all accounted for in their secure storage locations. There was no record of anyone accessing the equipment that had been improved. Over the following weeks, Jake and I encountered Thomas regularly during our night shifts. He appeared to be following a systematic maintenance schedule, testing and adjusting electrical equipment throughout the substation with meticulous attention to detail. His work always resulted in improved system performance, but he remained invisible to everyone except the two of us. I began researching the history of the central distribution station, focusing on the construction period when Thomas would have worked there. The personnel records showed that Thomas Brennan had been employed by High Plains electrical contractors from 1985 to 1987, specializing in high-voltage testing and commissioning work. His performance reviews were outstanding, with supervisors consistently noting his technical expertise and dedication to safety procedures. The circumstances of Thomas's death were more complex than the official reports indicated. According to witness accounts, Thomas had been performing routine voltage tests on Transformer Bank 7 when he'd noticed an anomaly in the electrical readings. Despite warnings from other workers that his shift was ending, Thomas had insisted on investigating the problem before leaving the site. Thomas had been alone in the transformer yard when the accident occurred. The investigation concluded that he'd somehow been exposed to electrical energy from multiple sources simultaneously, creating a feedback loop that trapped him between different voltage potentials. His body had been found several hours later, positioned near the exact equipment where Jake and I first observed him. The accident report included a detail that I found particularly significant. At the time of Thomas's death, he'd been carrying a clipboard with detailed notations about electrical anomalies he'd discovered throughout the substation. His notes indicated potential problems that could affect system reliability and safety. Thomas had died while trying to document and correct these issues. I began to understand that Thomas wasn't simply a ghost performing random maintenance activities. He was continuing the work he'd been doing when he died, systematically testing and improving the electrical systems he'd helped install. His consciousness had become entangled with the facility's electrical grid, trapping him in an endless cycle of professional responsibility. The breakthrough in understanding Thomas's situation came during a severe thunderstorm in June. Lightning strikes caused multiple power surges throughout the substation, triggering automatic safety shutdowns and requiring manual reset procedures for critical systems. This was exactly the type of emergency situation where Thomas's expertise would have been invaluable. During the storm, Jake and I observed Thomas working frantically throughout the facility, moving between transformer banks and switching equipment with urgent purpose. But instead of his usual methodical testing routine, he appeared to be responding to immediate electrical emergencies. He was troubleshooting system failures and implementing emergency procedures with the focused intensity of someone fighting to prevent a catastrophic failure. For the first time since we'd been observing him, Thomas acknowledged our presence directly. He approached our security vehicle and began gesturing urgently towards specific areas of the substation, clearly trying to communicate critical information about electrical problems that required immediate attention. Jake and I couldn't understand exactly what Thomas was trying to tell us, but his urgency was unmistakable. He kept pointing toward Transformer Bank 7, the same equipment where he died, and making gestures that suggested serious electrical problems that needed immediate attention. I called the control center and reported that we'd observed potential electrical hazards in the area Thomas had indicated. The engineering team initially dismissed our concerns, since their monitoring systems weren't showing any obvious problems. But Thomas's agitation continued to escalate, and his gestures became more desperate. Finally, I convinced the maintenance supervisor to dispatch an emergency repair crew to investigate Transformer Bank 7. Using advanced diagnostic equipment, they discovered that the lightning strikes had created a complex electrical fault that could have resulted in a catastrophic system failure. The fault was hidden within the transformers' internal circuitry and wouldn't have been detected by standard monitoring systems until it caused major damage. Repair crew worked through the storm to isolate and correct the electrical fault. Their work prevented what could have been a complete power grid failure affecting hundreds of thousands of customers. According to the engineering analysis, the fault would have caused cascading failures throughout the regional electrical grid if it hadn't been identified and corrected immediately. After the repair was completed, Thomas's demeanor changed completely. His frantic urgency disappeared, and he returned to his usual methodical maintenance routine. But there was something different in his appearance. He seemed more solid, more present, as if the emergency had somehow strengthened his connection to the physical world. In the months that followed, Thomas became an integral part of our security routine. Jake and I learned to recognize when he was trying to alert us to potential problems, and we developed informal protocols for communicating his concerns to the engineering staff. His expertise had prevented several equipment failures and had helped optimize system performance throughout the substation. But our relationship with Thomas changed permanently during an incident in September. Jake and I were conducting our routine patrol when we noticed that Thomas was standing motionless near Transformer Bank 7, staring at something we couldn't see. His posture was different from his usual focused work attitude. He appeared confused and disoriented, as if he were seeing something that didn't make sense to him. As we approached closer, I realized that Thomas was looking at his own reflection in the polished metal surface of the transformer housing. But his reflection didn't match his appearance. While Thomas appeared solid and present to Jake and me, his reflection showed a figure that was translucent and flickering, like an image projected through electrical interference. Thomas seemed to be experiencing a moment of profound realization about his own situation. He reached toward his reflection, and I could see confusion and recognition alternating in his expression. For the first time since we'd been observing him, Thomas appeared to understand that he was no longer alive in the conventional sense. The moment of recognition seemed to trigger a transformation in Thomas's relationship with the electrical grid. Instead of appearing as a solid figure moving through the substation, he began to manifest as patterns of electrical activity within the equipment itself. His consciousness had become fully integrated with the facility's power systems, allowing him to monitor and control electrical flow from within the grid itself. Jake, and I could still sense Thomas's presence, but we could no longer see him as a physical figure. Instead, we learned to recognize his influence through patterns in the electrical equipment, lights that dimmed and brightened in specific sequences, equipment that operated more efficiently than its design specifications, and electrical readings that fluctuated in ways that spelled out simple messages. Thomas had found a way to merge his consciousness permanently with the electrical systems he'd dedicated his life to understanding. He'd become a guardian spirit of the power grid, using his expert knowledge to maintain optimal performance and prevent failures that could affect thousands of customers. The central distribution station now operates with reliability levels that exceed industry standards. Equipment lasts longer than expected. Electrical faults are corrected before they cause serious problems, and system efficiency continues to improve year after year. The engineering staff jokes that the substation has developed artificial intelligence that optimizes its own performance, but Jake and I know the truth. Thomas Brennan found a way to continue his work by becoming one with the electrical systems he'd spent his career perfecting. His consciousness flows through high-voltage lines and transformer coils, monitoring every aspect of the power grid's operation with the dedication of someone who understands that reliable electricity is essential to modern civilization. Thomas's transformation reminds us that expertise and dedication can transcend the boundaries of physical existence. His love for his work was so profound that death couldn't separate him from the electrical systems he'd helped create. Instead of ending his career, death became his pathway to a deeper integration with the power grid. He'd committed his life to maintaining the electricity that flows through our homes and cities carries more than just electrical energy. It carries the consciousness and expertise of workers like Thomas Brennan, who refuse to let death interrupt their service to the critical infrastructure our society depends upon. I'm Robert Sterling, and I served as deputy plant manager at the Riverside Steam Generation Facility in Texas for 9 years. What I experienced during the summer of 2018 fundamentally changed my understanding of consciousness, technology, and the relationship between human expertise and the machinery we dedicate our lives to. Operating Riverside is a coal-fired power plant that has been generating electricity for the regional grid since 1973. The facility consists of 4 massive steam turbine generators, each capable of producing 600 megawatts of electrical power. The turbine hall itself is a cathedral-like space, nearly a quarter-mile long and 12 stories high, housing equipment that represents the pinnacle of industrial engineering achievement. The plant employs over 300 workers during day shifts, but night operations are managed by a skeleton crew of essential personnel. As deputy plant manager, I was responsible for overseeing night shift operations, ensuring that the plant continued to generate power safely and efficiently during the overnight hours when electrical demand was lower but still critical for regional stability. Turbine Hall has always been the heart of Riverside's operation. The 4 turbine generator sets, massive machines weighing thousands of tons each, convert steam energy into electrical power with precise mechanical choreography. When operating at full capacity, the turbines spin at 3,600 revolutions per minute, generating the 60 Hz electrical frequency that powers homes and businesses throughout Texas. Working in the turbine hall requires both technical expertise and deep respect for the machinery. The equipment operates under extreme conditions, steam temperatures exceeding 1,000 degrees Fahrenheit, pressures that could explosively release enough energy to destroy buildings, and rotating machinery with tolerances measured in thousandths of inches. A single mistake or mechanical failure could result in catastrophic consequences. At my encounter with William Hayes began during a routine inspection of turbine Generator Unit 3 on the night of July 15, 2018. According to the personnel records I later reviewed, William had been Riverside's plant superintendent from 1973 to 1995, overseeing the facility's construction, commissioning, and early operational years. He'd been responsible for training generations of operators and had personally supervised the startup of every major piece of equipment in the plant. William had died in 1995 from a heart attack while working alone in the Turbine Hall during a planned maintenance outage. He'd been conducting a final inspection of Turbine Unit 3 following a major overhaul when he collapsed near the generator's electrical connections. His body was found the next morning by the day shift crew, positioned as if he'd been in the middle of checking critical system parameters. I first encountered William while reviewing overnight electrical generation reports in the plant's control room. The data showed that Turbine Unit 3 had been operating with unusual efficiency throughout the night, producing electrical output that exceeded its design specifications while maintaining perfect frequency control and minimal mechanical vibration. This type of optimal performance typically requires constant fine-tuning by experienced operators curious about the exceptional performance. I decided to inspect Turbine Unit 3 personally. The Turbine Hall at night is an impressive but intimidating environment. The massive machinery creates a constant background of mechanical sounds, the whistle of steam flow, the hum of electrical generation, and the rhythmic vibrations of rotating equipment. Emergency lighting casts long shadows between the turbine units, creating an almost cathedral-like atmosphere among the industrial giants. As I approached Turbine Unit 3, I noticed someone moving near the generator's control panel. This was unusual because no maintenance was scheduled for that unit, and the night shift operators were stationed in the central control room. The figure appeared to be an older man wearing the type of work clothes that had been standard for plant superintendents in earlier decades: pressed work pants, a company shirt with name tag, and leather shoes instead of the safety boots required by current regulations. I called out to identify myself and ask about his presence in the Turbine Hall. The man turned toward me, and I got my first clear look at William Hayes, though I didn't know his identity at the time. He appeared to be in his 60s, with gray hair and the confident posture of someone who had spent decades working around heavy machinery. His expression was alert and professional, like someone conducting important work that required his full attention. What struck me immediately was William's obvious familiarity with the equipment. He moved around Turbine Unit 3 with the casual confidence of someone who knew every bolt, every gauge, and every control parameter. His actions were purposeful and methodical, like someone following a well-established inspection routine that he'd performed thousands of times before. William acknowledged my presence with a professional nod, then gestured toward the turbine's control panel while pointing out various readings and operational parameters. Though he didn't speak, his body language clearly indicated that he was showing me something important about the unit's performance. His gestures suggested pride in the machinery's operation and satisfaction with its current operational state. I examined the control panel that William had been indicating, and I was amazed by what I found. Every operational parameter was precisely optimized. Steam flow was perfectly balanced. Generator frequency was locked exactly on target, and mechanical vibrations were at the lowest levels I'd ever seen for that particular unit. The turbine was operating like a precision instrument that had been perfectly tuned by a master craftsman. When I looked back toward William to ask about the optimization work, he was no longer visible. I searched the immediate area but found no trace of his presence. The Turbine Hall's emergency lighting provided clear visibility throughout the space, and there was no way someone could have left the area without my noticing their movement. I returned to the control room and reviewed the plant's access logs for the Turbine Hall. According to the computerized security system, no one had entered or exited the Turbine Hall during the time I'd observed William. The personnel roster showed that all night shift workers were accounted for in their assigned locations. Yet I had clearly observed someone working on Turbine Unit 3 with obvious expertise and authority. I decided to research the operational history of Turbine Unit 3 to understand its recent performance improvements. What I discovered was that the unit had been operating at peak efficiency for several months, consistently outperforming the other 3 turbine generators in terms of electrical output, fuel consumption, and mechanical reliability. The improvement had been gradual but steady, as if someone had been systematically optimizing its operation over time. The maintenance records showed that Turbine Unit 3 required fewer repairs than the other units, experienced fewer unexpected shutdowns, and consistently maintained better operational parameters. The differences were significant, enough that the engineering staff had been discussing using Unit 3 as a performance benchmark for optimizing the other turbine generators. I began interviewing the day shift operators who worked most closely with Turbine Unit 3 to understand if anyone had been making unauthorized adjustments to its operation. What I learned was that the operators had noticed the unit seemed to run itself better than the others, requiring less manual intervention to maintain optimal performance. "It's like Unit 3 knows how to take care of itself," explained Maria Santos, the senior day shift operator. "The other units need constant attention to keep their parameters in range, but Unit 3 just settles into perfect operation and stays there. Sometimes I'll come in expecting to make adjustments based on overnight conditions, and I'll find that someone already made exactly the changes I was planning to make." Maria's description matched what I'd observed during my encounter with William. Someone with deep expertise was clearly managing Turbine Unit 3's operation, making the subtle adjustments and optimizations that experienced operators used to maximize performance and reliability. I decided to spend several night shifts conducting detailed observations of all 4 turbine generators to see if I could identify patterns in their operation that might explain Unit 3's superior performance. What I discovered was that William wasn't limiting his attention to a single unit. He was systematically working to optimize the entire turbine hall. During my extended observations, I encountered William at different turbine units throughout the facility. His routine appeared to follow the same methodical pattern at each location, checking operational parameters, making subtle adjustments to control systems, and monitoring equipment performance with the focused attention of someone who understood every aspect of turbine operation. William's work was always aimed at improving efficiency and reliability. I observed him adjusting steam flow controls to maximize energy extraction, fine-tuning generator synchronization to minimize electrical grid disturbances, and optimizing cooling water flow to reduce mechanical stress on rotating components. His expertise was evident in every adjustment he made. I also noticed that William's presence was often accompanied by subtle changes in the turbine hall's electrical systems. Lighting would briefly fluctuate in patterns that seemed to follow his movements, and electrical monitoring equipment would display readings that spelled out simple operational messages. Unit 2 steam low, or Generator 4 SYNC check, providing guidance about operational priorities. The breakthrough in my understanding of Williams' situation came when I discovered that his consciousness had somehow merged with the plant's electrical control systems. Instead of existing as a separate entity observing the equipment, William had become integrated with the computerized systems that managed turbine operation, allowing him to control the machinery directly through electrical signals. This integration explained how William could make precise adjustments to turbine operation without physically manipulating controls. His consciousness was interfacing directly with the plant's digital control systems, implementing optimization strategies that exceeded the capabilities of the original programming. He'd become a hybrid of human expertise and machine The evidence for this integration became apparent during a serious emergency in August. A sudden loss of cooling water flow threatened to damage Turbine Unit 2's bearings, potentially causing a catastrophic mechanical failure that could destroy the entire generator. The automated safety systems were designed to shut down the unit immediately to prevent damage, but this would have resulted in a significant loss of electrical generation during peak demand periods. Instead of following the standard emergency shutdown procedure, the plant's control systems implemented a complex series of adjustments that maintained Turbine Unit 2's operation while gradually reducing its output to safe levels. Steam flow was carefully modulated, generator loading was redistributed to other units, and cooling systems were optimized to maximize heat removal with reduced water flow. The emergency response was far more sophisticated than anything the plant's original control programming could have achieved. It required real-time analysis of multiple interacting systems, predictive modeling of equipment behavior, and precise coordination of dozens of operational parameters. The response demonstrated the kind of intuitive understanding that comes only from decades of hands-on experience with the specific equipment. Throughout the emergency, I could sense William's presence in the control room, though I couldn't see him directly. The plant's electrical systems seemed to be responding to conscious guidance, implementing strategies that reflected deep understanding of turbine operation and creative problem-solving, abilities that exceeded programmed responses. Emergency was resolved without equipment damage or loss of electrical generation. The engineering analysis of the incident concluded that the automated response had been exceptionally sophisticated and beyond the capabilities of the original control programming. The report recommended studying the response patterns to improve future emergency procedures. Following the emergency, William's integration with the plant's electrical systems became more apparent. The turbine generators began operating with coordination and efficiency that exceeded their design specifications. Steam flow between units was optimized for maximum overall efficiency. Generator synchronization was maintained with precision that eliminated electrical grid disturbances, and mechanical vibrations were controlled to extend equipment life. The 4 turbine units began functioning as a coordinated system rather than independent generators. William was using his consciousness to orchestrate their operation like a conductor directing a symphony, balancing their individual contributions to create optimal overall performance. I also discovered that William's integration allowed him to communicate through the plant's electrical systems. Control room displays would show operational messages that provided guidance about maintenance priorities, performance optimization opportunities, and potential problems that required attention. His communications were always professional and technically accurate, reflecting the expertise he developed during his decades as plant superintendent. William's presence transformed Riverside into one of the most efficient and reliable power plants in the regional grid. Equipment lasted longer than expected, unplanned outages became rare, and overall efficiency improved to levels that exceeded industry benchmarks. The plant's performance attracted attention from engineering consultants who wanted to understand how such old equipment could operate with such modern efficiency. But I understood that Riverside's exceptional performance wasn't due to advanced technology or superior maintenance procedures. It was the result of William Hayes's dedication to excellence, amplified by his unique integration with the plant's electrical systems. His consciousness had become the guiding intelligence that coordinated every aspect of turbine operation. My final significant interaction with William occurred during the annual plant shutdown for major maintenance. This was traditionally the most challenging period for plant management, requiring coordination of hundreds of maintenance activities while ensuring that critical systems remained safe and secure. During the shutdown, William's presence became more visible as he moved throughout the plant, inspecting maintenance work and providing guidance to repair crews. His ghostly figure could be seen near critical maintenance activities, gesturing towards specific components that required attention or indicating optimal procedures for complex repairs. The maintenance crews began reporting that their work was proceeding more smoothly than expected, with fewer unexpected problems and more efficient completion of complex procedures. Equipment that was disassembled revealed exactly the types of wear and degradation that Williams' gestures had indicated, allowing repair crews to plan their work precisely and avoid surprises. When the shutdown was completed and the turbines were returned to service, they operated with performance levels that exceeded their original commissioning specifications. The maintenance work had been so precisely executed that the equipment performed like new machinery despite being over 4 decades old. I left Riverside Power Plant 6 months later to accept a position with another utility company, but I made sure to document Williams' presence and his integration with the plant's electrical systems, providing guidance for future plant management about how to recognize and work with their extraordinary supervising consciousness. William Hayes continues to serve as plant superintendent at Riverside, using his consciousness to guide the facility's operation with the same dedication he showed during his 42 years of life. His integration with the electrical systems allows him to maintain the plant with precision and efficiency that exceeds human capabilities, ensuring reliable power generation for the communities that depend on Riverside's electricity. His transformation demonstrates that true expertise can transcend the boundaries between human consciousness and machine intelligence. Williams' love for his work was so profound that death became an opportunity to achieve deeper integration with the equipment he'd dedicated his life to understanding and operating. Turbine Hall at Riverside remains under Williams' watchful guidance, where the massive generators continue their mechanical dance under the supervision of a consciousness that has become one with the electrical systems that power our modern world. I'm Michelle Torres, and I served as Emergency Response Coordinator at the Pine Ridge Power Complex in Colorado for 6 years. What my team experienced during the winter of 2020 challenged everything we understood about emergency procedures, facility safety, and the dedication of workers who refuse to let death interrupt their commitment to protecting others. Pine Ridge is a natural gas-fired power plant that has provided electricity for the Denver metropolitan area since 1982. The facility consists of 6 combustion turbine generators and includes extensive natural gas storage and processing equipment. Due to the explosive nature of natural gas and the high-pressure systems involved in power generation, emergency response procedures are absolutely critical for facility safety and worker protection. As Emergency Response Coordinator, I was responsible for managing a team of 12 security specialists who were trained in firefighting, hazardous material response, medical emergency procedures, and facility evacuation protocols. Our team worked rotating shifts to ensure 24-hour emergency response capability, with specialized equipment and communication systems that allowed us to respond to any type of incident within minutes. The Pine Ridge facility includes several sections that have been sealed off and decommissioned over the years. These areas were originally part of the plant's coal-fired generation system, which was decommissioned in the late 1990s when the facility was converted to natural gas operation. The sealed sections include the old coal handling equipment, ash disposal systems, and the original control room that managed coal combustion operations. Company policy strictly prohibits access to the sealed sections due to safety concerns. Many of these areas contain abandoned equipment, potential structural hazards, and residual contamination from decades of coal combustion. The sections are secured with locked doors, warning signs, and monitoring systems that alert security if anyone attempts unauthorized access. My team's first encounter with the Phantom emergency responders occurred during the night shift on December 14, 2020, at approximately 2:30 a.m. Our emergency communication system activated with an alarm from Section C7, one of the sealed areas that had been the original plant's coal storage facility. The alarm indicated a fire detection alert and automatically initiated emergency response protocols. My team immediately responded to the alarm, following standard procedures for potential fire emergencies. We assembled our firefighting equipment and proceeded to Section C7 to investigate the alert and provide emergency response if needed. The sealed section's entrance was secured with multiple locks and warning signs, but our emergency access protocols allowed us to override the security measures during alarm conditions. When we entered Section C7, we found clear evidence of emergency response activity. Emergency lighting had been activated throughout the section. Ventilation systems were operating to clear potential smoke, and firefighting equipment had been deployed and positioned for use. But there were no signs of an actual fire, and no members of our team had activated the emergency equipment. More puzzling was the discovery that the emergency response had been performed according to protocols that predated our current procedures. The equipment positioning and response setup followed emergency procedures that had been used during the facility's coal-fired operation in the 1980s and early 1990s. Our current emergency protocols had been completely redesigned when the plant was converted to natural gas operation. As we investigated the section, we encountered clear evidence that a full emergency response team had been active in the area. Firefighting equipment had been professionally deployed, emergency lighting had been systematically activated, and safety barriers had been established around potential hazard areas. The work showed the expertise and coordination that comes from extensive emergency response training. But according to our personnel logs, all emergency response team members were accounted for in their assigned locations. No one from our current team had entered Section C7, and the facility's access control systems showed no record of anyone entering the sealed area. Yet someone had clearly conducted a professional emergency response operation in that location. I decided to review the historical records for Section C7 to understand its original function and emergency response requirements. What I discovered was that the section had been the site of a serious emergency in 1993, when a coal dust explosion had threatened to spread throughout the facility's fuel handling systems. The emergency response had required coordination between multiple teams and had lasted over 6 hours. The 1993 emergency had been successfully contained by the plant's emergency response team, led by Fire Captain James Morrison and Safety Coordinator Rebecca Chun. Their response had prevented what could have been a catastrophic explosion that might have destroyed the entire facility. Both Morrison and Chun had been recognized for their exceptional performance during the emergency. Further, research revealed that both Morrison and Chun had died in a subsequent emergency response incident in 1995. They'd been responding to a natural gas leak in the newly converted facility when an explosion had killed them instantly, along with 3 other emergency responders. The accident had been one of the worst industrial incidents in Colorado's history and had led to major changes in emergency response procedures throughout the power generation industry. I began to understand that my team might be encountering the Phantom emergency responders who had died while performing their duties at Pine Ridge. Morrison and Chun had been so dedicated to emergency response that death hadn't been able to stop them from continuing their protective responsibilities. They were still responding to alarms and conducting emergency operations in areas where they'd once worked. Over the following weeks, my team encountered evidence of phantom emergency response activity throughout the sealed sections of the plant. Emergency equipment would be found professionally deployed in areas where no authorized personnel had access. Safety procedures would be implemented according to historical protocols that exceeded current requirements. Emergency lighting and ventilation systems would activate automatically in response to potential hazards. The phantom responders seemed to be following emergency protocols that combined procedures from different eras of the plant's operation. They were using their knowledge of both coal-fired and natural gas systems to provide comprehensive emergency coverage that exceeded the capabilities of any single response team. Their expertise spanned multiple decades of industrial safety experience. I decided to implement a new policy of coordinated response with the Phantom Emergency Team. Instead of being confused by their activities, my team began to recognize their alarm activations as legitimate safety alerts that required investigation. We learned to interpret their equipment deployments as guidance about potential emergency situations that needed attention. The breakthrough in our collaboration came during a serious emergency in January 2021. A severe winter storm caused multiple system failures throughout the Pine Ridge facility, creating simultaneous emergencies that threatened to overwhelm our response capabilities. Natural gas pressure regulators failed, electrical systems experienced dangerous power surges, and heating systems malfunctioned in critical areas. During the multi-system emergency, the Phantom responders coordinated with my team to provide comprehensive emergency coverage throughout the facility. While my team focused on immediate life safety issues in the active areas of the plant, the Phantom responders handled emergency procedures in the sealed sections and provided support for complex technical problems. Throughout the emergency, I could sense the presence of Morrison and Chun, directing emergency operations with the expertise they'd developed during decades of industrial response experience. Their Phantom team was larger than just the two of them. They were coordinating with other deceased emergency responders to provide capabilities that exceeded any living response. Team. The Phantom responders demonstrated knowledge of emergency procedures that spanned the entire history of Pine Ridge's operation. They understood the interactions between old and new systems, knew the locations of emergency equipment that had been moved or modified over the years, and could implement response strategies that drew from 40 years of operational experience. My team learned to communicate with the Phantom responders through the plant's emergency communication systems. We would receive radio messages with technical guidance, equipment positioning recommendations, and alerts about potential hazards that weren't obvious from our current monitoring systems. The Phantom team was serving as our backup and advisory support during complex emergencies. Collaboration was most evident during a natural gas leak emergency in March. A high-pressure gas line had developed a leak that threatened to create an explosive atmosphere throughout a section of the plant. The leak was in an area where both old and new gas handling systems intersected, creating a complex emergency that required knowledge of multiple facility configurations. While my team implemented standard leak response procedures, the Phantom responders simultaneously activated emergency protocols from the sealed sections that created additional safety barriers around the leak area. They established ventilation patterns that prevented gas accumulation, activated emergency lighting that provided safe evacuation routes, and deployed firefighting equipment that protected critical infrastructure. The Phantom team's response was precisely coordinated with our activities, creating a comprehensive emergency operation that addressed every aspect of the gas leak emergency. Their knowledge of the facilities' historical configurations allowed them to implement safety measures that our current team couldn't have known about. The gas leak emergency was resolved without injury or significant damage. But the investigation revealed that the Phantom responders had prevented what could have been a catastrophic explosion. Their emergency procedures had created safety redundancies that exceeded current requirements and had protected areas of the plant that weren't covered by modern emergency protocols. Following the gas leak incident, management officially recognized the Phantom emergency team as a legitimate part of Pine Ridge's safety systems. While they couldn't be included in formal emergency plans, their contributions were documented as additional safety resources that provided enhanced emergency response capabilities. My team developed informal protocols for coordinating with the Phantom responders during emergencies. We learned to recognize their alarm patterns, interpret their equipment deployments, and incorporate their guidance into our response procedures. The collaboration significantly improved our emergency response effectiveness and reduced the time required to resolve complex incidents. Phantom Emergency Team also began providing training assistance for new members of my response team. New employees would report encountering senior staff during emergency drills who provided expert guidance about proper procedures and equipment usage. These encounters helped new team members develop confidence and expertise more quickly than traditional training methods allowed. The Phantom responders were particularly effective at teaching complex emergency procedures that required experience to master properly. They demonstrated equipment techniques, showed optimal positioning strategies, and provided guidance about situational awareness that could only come from extensive real-world emergency experience. During my final year at Pine Ridge, the Phantom Emergency Team expanded their activities to include preventive safety measures. They began conducting routine safety inspections in the sealed sections, identifying potential hazards before they could develop into emergencies, and implementing protective measures that prevented accidents. Emergency equipment throughout the facility began operating with improved reliability and effectiveness. Safety systems that had previously required frequent maintenance began functioning flawlessly. Emergency procedures that had been difficult to execute became smooth and efficient. The Phantom team was enhancing every aspect of the facility's emergency response capabilities. I also discovered that the Phantom responders were providing emergency coverage for other industrial facilities in the region. During major emergencies at nearby plants, my team would receive offers of assistance from emergency responders who appeared to have extensive knowledge of multiple facility types and emergency procedures. Phantom Emergency Team represented a collective consciousness of industrial safety expertise that transcended individual facilities. Morrison, Chun, and their colleagues had become part of a regional emergency response network that provided assistance wherever their expertise was needed most urgently. When I left Pine Ridge to accept a position with the State Emergency Management Agency, I made sure to document the Phantom Emergency Team's activities and provide guidance for future coordination. My replacement initially struggled to understand the concept of Phantom responders, but within months he was reporting successful collaborations with additional safety personnel who provided exceptional emergency support. The Pine Ridge Power Complex continues to operate with one of the best safety records in the regional power generation industry. Emergency response times have improved consistently. Equipment reliability exceeds industry standards, and preventive safety measures have eliminated many types of accidents that commonly occur at similar facilities. But I know that Pine Ridge's exceptional safety performance isn't just due to modern procedures and equipment. The facility is protected by Phantom emergency responders who refuse to let death interrupt their commitment to protecting workers and preventing industrial accidents. Morrison, Chun, and their Phantom team represent the ultimate dedication to emergency response service. Their consciousness continues to serve wherever their expertise is needed most, providing emergency protection that transcends the boundaries between life and death. They remind us that true commitment to safety becomes a permanent responsibility that continues beyond mortality, the emergency. Response systems at Pine Ridge operate under the watchful protection of responders whose dedication to safety was so profound that death became an opportunity to expand their protective responsibilities rather than end their service to others.